had to go through and redo your homework for chapter 5 for the first 3 sections because some of y'all went ahead and did homework in chapter 5, and I don't remember telling y'all to do that. So thanks to those people that went ahead of me, I had to cancel out the old homework and recreate the homework. So thank you for that extra work. I did post, let me go ahead and look for it. I did post the 5.1 through 5.3 homework today. So you can go ahead and get started. It's not a lot of antiderivatives. In other words, it's a lot of geometric areas, making sure you know how to graph a line, kind of a lot of review work. You don't get into the actual antiderivatives until you get into 5.3. So here is the homework, and there is the 5.1 through 5.3 homework revised. I've got to review the other ones because, like I said, some of y'all went ahead and did a little bit in every single chapter 5, and after one person has done it, I cannot change it. So I have to delete it and recreate it. So I'm doing them one section at a time. So this morning I did 5.1, 5.2, and 5.3. So what we're going to do is I'm going to go through and look at a few of these questions with you, and then we'll focus on 5.3 by the end of the class. And then you'll see, you know, because 5.3 and 5.4, let me see, and 5.5, yeah, 5.3, 5.4, and 5.5 constitutes the bulk of your test. 5.2, 5.3, and 5.5. So let's go ahead and look at 5.1. And you see there's not a lot of questions. So you could put it off until the morning of the test. So you can do 6 sets of homework, you know, in a 24-hour period. Okay. Let me just look and see. There are a couple of Riemanns, but I'm going to do them with you. So that way, you know, you can see. This is just a graphing review question. Make sure you know, at x is equal to 2, x is equal to 4, x is equal to 5. I think y'all can read that that's pretty self-explanatory. Graph, make sure you know how to graph a square root, and I think y'all can do that. Piecewise function. You've got, suppose an object moves along a line at 13 meters per second from 0 to 3 and 22 from 3 to 5. So you got a line at 0 to 3 and you got a line at 3 to 5. So it's either going to be this one, maybe this one, depending on where it falls. Then you got to look at the dots. This one's going to have an open circle and a closed circle. So it might be that one. This one's going to have a closed circle and a closed circle, so it looks like delta. So again, these are not antiderivative problems. These are just test questions or homework questions. That is pretty much algebra review. Yes. Okay, here's one. This is a test question, but it's not a derivative question or antiderivative question. This is a question based on geometry. It says, suppose the area of the region bounded by the graph f of x shown below and x-axis by dividing the interval 2 through 6 into 4 rectangles. That's what that's what subinterval means. 4 rectangles. Use a right and left Riemann sum to obtain the difference approximations. Draw the approximate. So left and right. So I'm looking right quick. You might have to blow them up. I don't know, can you blow them each up? Yeah, you can. There we go. Okay, we're going from 2 to 6. So 2 to 6, 2 to 6, 2 to 6, and 2 to 6. So all of your graphs are going from 2 to 6, so that you check that. All of your graphs are following this right here. But this one is right, and this one is left. So I would be A and D. This one, the excess is on the right, which is the right, and this one is on the left, so that would be the left. Okay. All right, so let's look at this one. Since we did A and, why did it not choose? Okay, we're doing, okay. Use the specified rectangles, approximate the area. Why didn't it do A? I thought I chose A. Did I not choose A?
I think you can only choose one.
I'm sorry, what?
I think you can only choose one answer.
Okay, well, it says use a right and left Riemann sum. So I don't know. Okay, we'll do this one. Okay, left, this is left. Okay, your height is 8. So I'm gonna blow this up a little bit. And I'm gonna draw it right here on the paper for you. And we've got 2, 3, 4, 5, 6, 7, 8, and there's 6. And we've got one at 3. And one at 4. And of course, mine's not showing up as good as theirs is. And one at 5. And this height is at 8.
Priority 1 message coming in on secure
And this
channel.
height is at 7. And this height should be at 6. And this height should be at 5. Okay, so here we go. There is the drawing, and of course mine is a little bit off, but to get the gist of it. So we're gonna find this one right here, and the surplus is to the left. Okay, here's the surplus right here. And here's the actual area of under the curve. Okay, so what is the area of that orange rectangle? Well, this base right here is delta x is equal to 1. So the base is 1, and the height is what? 8. So 8 square units. And then you're going to do the same thing here. And I'm going to use blue. We don't have any excess on this one, according to my sketch, because my sketch sucks. But the whole point is, there we go. And that's going to be delta x is equal to 1. And that's going to be 7. So that's 7 square units. And of course, this is going to be 6 square units, and this is going to be 5 square units. And 8 plus 7 is 15, 26. So that one is equal to 26 square units. So let's go back to the graph and go down, and that should be 26. Okay, now it says which are the graphs in which graph below are the selected points, the left endpoints. Okay, that means that the surplus is on the right. So that would be A. Looks like A. Let me make sure. Yeah, the surplus is on the right. So I believe it would be A. Nope. Let me look. These graphs are not very, okay, that's not it. Should be this one, delta. There we go. Let me blow it up so you can see it. And see these, the surplus is on the right. Okay? So when you left endpoints, the surplus is on the right. Right endpoints, they're on the left. So I'm going to draw it again for you. And this is 2. So we're starting at 2, going up to 8, like that, and then going up, whatever. And then this is at 2, 1, 2, and 2 is at 7. Two, three, 4, 2, 3, 4. I'm trying to get this done right, so just bear with me a minute. Well, I don't have mine drawn exactly the way they do, so mine's a little bit off. And this one is up like that, and this one is up like that. Okay, so here's my drawing, which really sucks, but there we go. And this is 2, 3, 4, 5, 6. Now delta is still 1, so you got a 1 here, 1 here, 1 here, and 1 here. But the heights are different because this is 7, I believe. Let's look and see. Yeah, that first one's at 7. This one's at 8. This one's at 7. This one's supposed to be at 7, sorry. That one's supposed to be at 7. And this one is at 5. So I've got it really messed up. Okay, so we've got the first one is 7 times 1, that's 7. The second one is 1 times 8 is 8. The third one is 7. And the fourth one is 5. And that one is 7 plus 8 is 15, 27. So by using Ryman's left and right, you get within 1 square unit of each other. And that's left and right. Right, the excess is on the left. Left, the excess is on the right. And you see it better with their drawing because their drawing shows it the way it's supposed to be. There it is. If the left endpoints, the excess is on the right. The right endpoints, the excess is on the left. Right, there it is right there. And that's Ryman's. And they do a midpoint, and the midpoint would be right here, in which they would, you'll see that in just a minute. So that's how you do Ryman's. Basically, just do the area of each rectangle and add it up. And you got to know the difference between left and right. Right, the excess is on the left. Left, the excess is on the right. Let's see what other questions I got on this one. Oh, we're not through with this one. Oh, 27. Did we not get 27 on that one?
Yeah, we did.
They got 28. Let's see. 7 is 14. And 8 is, let's see. 7 and 7 is 14. 14 and 6 is 20. And 8, 28. Well, I must have added something wrong.
You said that last one was 5.
Oh, it's 6. Okay, my bad. It's 28. Well, I didn't draw it right. That's why. It should have been a 6 instead of a 5. There we go. I'll show you what I did wrong. I put a 5 right here. That's supposed to be a 6. There we go. 28. Like I told you before, I want you to be familiar with Riemann in case somebody asks you, you know, that's Riemann. You add up the rectangles. All right, here's an example of one. I'm gonna draw you. There's the graphs right there. Now, I want you to read the question. This is a test question because it's on Riemann. And it says the velocity of an object moving along a line is given by this formula, 4t squared plus 4, from 0 to 4. Divide the interval into 4 intervals, then divide it into 8. And tell me what the areas are. So technically, you could just look at this and tell me what the areas are. Now, does anybody notice something different about these two versus these two are midpoints? See, the height of the rectangle is intersecting at the midpoint instead of going left and right. There's 3 Riemanns. There's left, the excess is on the right. There's right, the excess is on the left. And then there's the midpoint. This is a midpoint. So I want you to draw those 2 graphs in your notes. And I want you to make a note that these are midpoints. Now I'm going to try to draw these. I'm going to try to blow them up a little bit more. Did I make this bigger? I guess not, but I can draw it. And I'm going to ask y'all, what are they trying to show y'all with this problem? I'll ask you that in just a minute. So that's it. Let's see, 10, 20, 30, 40. So that's y-intercept of 5. And it's going up like a parabola, like that. And we've got 4 intervals based on the midpoints. And that is 1, 2, 3, 4. And this looks like, oh, great. Going to have to really guess on these Y's if they want you to. So what I'm going to do is I'm going to pull up my handy dandy whiteboard and I'm going to use an area No, I don't want to check for updates. I'm going to use a ruler, straight edge. I don't even know if they're going to ask for the, but I'm going to try to give y'all. That one looks like around 7. So that first one is going to be 7 times 1. So that first one is going to be 7 times 1. Because it's a little bit above 5, and then it's not quite halfway. That'd be 8. So I'm going to say that one's around 6 or 7. This one, that one is what? Around 12. So I'm going to say 12 times 1 on that one. This one, oops, sorry. That one's pretty close to what? It's a little bit below, but I'm going to say 30 on that one. So that's 30 times 1. And then this one, would y'all say that's around 42? Around 52. 50, there's 50. Let's see, that would be 55. I'd say 52. Now, if you're doing the graph, of course, 52. So that'd be 52 times 1. Now, since we do have the algebra, we can plug in the points, and we'll do that in just a second. But I'm showing you how to do it graphically. All right, so let me erase all this. Let's go over to the other one. I want you to draw it out. And instead of 4, you got 8. Same graph at 5, going up. And instead of 4, you got 8. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And it's still 0 to 4. And there's no way it's going to be 7 on that first one. So 7 times 1, 7 times, let's see. That's going to be 0.5. 7 times 0.5. The base is 0.5 now, because 4 divided by 8 is 0.5. So the second one, it looks like what? 7? No, that first one may be about 6. Yeah, 6 times 0.5, 7 times 0.5. That third one looks right at like 10. 10 times 0.5. The next one, I'll have to take my line out. So the next one, that looks like right at 10. What does that one look like? Maybe 18. That one. I'm trying to get them where you can see them. There. So we left off at 10. So this one looks like what? 16 times 0.5. So that one's going to be 16 times 0.5. This one right here, that one looks like, let's see, 5 or 5, 10. No, this is, no, wait a minute. 10, 20, 30. What did you say? Let's say 35 because I believe it's a little bit crooked. So that would be 35 times 0.5. Make sure I got that last one right. 16, 5, 10, 15, 5, 10, 10, 20, 30. Yeah. 10, 20. I said that was about 15, 16. Okay. I'm making sure that I'm getting my numbers right. That second one, 10, 20. This looks like 25. I believe I got one of them wrong. That looks like a 25. I think that last one is 25. That one is 25. And then 10, 20. That one right there is around 16. That's this one. And then this one is around 10. This one is around 7. And then this one, it's easy to get them mixed up. And a lot of you are saying, well, why are you doing this? And because you need to be able to do this with your eyeballs, and you need to be able to do it with your calculator also. So you got 1, 2, 3, 4, 5, 6, 7, 8. You got 8 Ys. 1, 2, 3, 4, 5. I'm on the 5th one. So that means this one is what? That's 35. So I've got a number missing. I've got 6 times 0.5. I've got 7 times 0.5. I've got 10 times 0.5. And then I've got, let's see, that's 25 times 0.5. Y'all with me? And then 35 times 0.5. And then what is this? Let's see, 48 times 0.5. And then the last one is what? 60 at 0.5. Y'all check me. That's 40, 50, 60. 60 at 0.5. So now that we've done it by hand, let's take our handy dandy drawing, which mine does not look like theirs. Mine looks terrible, but I'm going to go ahead and show it to you anyway. There they are. And looks like we've got 7 times 1, 12, 30, that's 82. That's what, 94? 94, 101. What'd y'all get when you add those up? Somebody add those up for me. Did y'all get 101?
Yep, 101.
Okay, this one. All right, half of 6 is 3. Half of 7 is 3.5. Half of 10 is 5. Half of 25 is 12.5. Half of 48, I still think I've got something missing. Let's see, 1, 2, 3, 4, 5, 6. I still think I've got some missing. 12 times point, let's see, it's 12. 48 is 24. And 30, yeah, I've got one missing. 1, 2, 3, 4, 5, 6. I got 2 missing. So I don't know which one I've got missing. But if you add them all up, you're not going to get 101. You'll get 30, and that's the, what is that? That's 54. Yeah, 54 and 12.5 and 3.5 is 16. Plus 54 is 70. 70, I got 78 so far, but I've still got 2 missing. So I kind of messed up. Let me go back to the drawing and see if I can find it. These daggum things are so small. Okay, let me go at it again. All right, there's 6, 7, 10. 6, 7, 10. Then the next one is about 16. Maybe that's the one I'm missing. 16. So 16 would be 8. So add an 8 there. That's 16. And then this is 25. I got 25. And this is 35. Yeah, I don't have 35. Half of 35 is 17. So I've got 17 and 8. And 17 and 8 is 25. Plus 78 is, I think it's 103. Somebody add 78 plus 25. What's 78
Yeah,
plus
that's what I
25?
103.
102.
3.
102 or
103.
103, whatever. Okay? I thought it was 103. 78 plus 25. Somebody check me. Now, which one's more accurate? Well, of course, this one's more accurate because it's got the smaller rectangles. Now, a lot of you say, well, that's a jumbled mess. Yeah, it is a jumbled mess. That's why we have algebra. So you can find the midpoints by looking at the graph. Let's go back to the original graph. And what is between 0 and 1? 0.5. So you take that 0.5 and you multiply it by this right here. So this first point, 0.5, see where that purple line is right there? We're going to take that and we're going to do V of 0.5, and that's going to be 4 times 0.5 squared plus 4. And that's going to be equal to 4 times 0.25 plus 4. And what is 4 times 0.25? Well, what's 4 quarters? $1. So 0.5. Now what is the base of your drawing? The base is 1. See, the base of that rectangle is 1, and our height at the midpoint is 5. So 5 times 1 is equal to 5 square units. So by the algebraic process, we've just found the first rectangle is 5 square units. Okay, now we're going to do the second one. And we're doing Ryman's again. So if you're wondering. All right, somebody tell me what that dashed purple line, where is it at?
Midpoint.
It's at the midpoint, which is what? 1.5, right? Well, I'm not going to use 1.5. I'm going to use 3/2 because if I use 1/2 or if I use 1.5, I got to depend on the calculator. So I'm going to do V of 3/2 is equal to 4 times 3/2 squared plus 4. So equals 4 times 9/4 plus 4. 4's go out. 9 plus 4 is what? 13 times 1. That's 13 square units. So the second rectangle is 13 square units. Yeah, people do the 1.5, and then they have to rely on the calculator to finish the problem because they can't do it in their head. All right, let's do the third rectangle. The third rectangle is 5/2, right? 2.5, right? No. Let's see. No, that would be what? 2 1/4. No. That's 3. So, yeah, 5/2. So I'm gonna put in 5/2. So 5/2. V of 5/2 is going to be equal to 4 times 5/2 quantity squared plus 4. 4 times 25/4 plus 4. 25 plus 4 is 29 times 1, 29 square units. And then the last one is 3.5. Well, 3.5 is what? 7/2. So V of 7/2 is equal to, excuse me, 4 times 7/2 squared plus 4 is 4 times 49/4 plus 4. 53 times 1 is 53 square units. So the algebraic area of this midpoint Riemann sum is 53 plus 30 is 83 minus 1 is 82. 82 plus 5 is 87. Plus 13 is what? 100? Somebody check my math.
It is 100.
Thank you. 29 plus 53 plus 5 plus 13. Now, I'm not going to do the second part because that takes up too much class time, but I'm going to show you the first two. Okay, there's 1. So there's a 1/2. So this first midpoint is a 1/4. So that's going to be a 1/4. So you're going to do V of 1/4 is equal to 4 times 1/4 squared plus 4. So that's going to be 4 over 1/16 plus 4. And that cancels to 1/4 plus 4. So 4 1/4 is the height times 1 is the base. Let's see, what's the base? This should be 0.5. Let's look. The base, there's 1. Yeah, 0.5. So that's going to be times 0.5. So your first rectangle on the 8 rectangle is going to be 2.125. Somebody check my math. What's 4.25 times 0.5? Okay, nobody's going to do it. I'll do it on the calculator. Appreciate y'all helping me out. 4.25 times 0.5. Now that was very hard. Thank you. Appreciate the communication. Thank you. God, I hope it don't get worse than the Tide Pod generation. If it gets worse than the Tide Pod generation, we're all screwed. All right, so let's do the next one. I'm going to do the second one for you. So somebody tell me that's 0.75, isn't it? Yes or no? Isn't that midpoint at 3/4? Yes or no? Somebody say yes or somebody say no, please.
Yeah, that looks like 3/4.
Yes.
Thank you. 3/4, V of 3/4 is equal to 4 times 3/4 squared plus 4. 4 times 9/16 plus 4. 9/4 plus 32/4. I'm sorry, 30. Let's see, 16/4 is what? 25/4. And 25/4 is 8 1/4. Times 0.5. Well, half is going to be 4.125. Somebody check me.
25 divided by 4 is 6 1/4.
Thank you. So that's going to be 3.125. Thank you for the communication. Somebody check to see what's 6.25 times a half. What is it?
That's it right there.
So those first two out of 8, the area of these first two right here is 5.25. 5.25 square units right there. And then you keep going. Now y'all see why I don't show y'all rhyming sum, because it can be very what?
Tedious.
Time consuming.
Yeah, it can be very time consuming. And I just need y'all as a class to understand that you're taking rectangles, you're finding the area of those rectangles, and you're what? Adding them up. That's what I want you to see. Now, I don't need you to be experts at rhyming sum. I just need you to know what it is. Capiche? Thank you, class. Appreciate it.
Yeah.
Thank you. Here's another one. Now, this one's pretty simple. I'm going to blow it up. Okay, this is the left. The points are hitting the line on the left. This is the right. The points are hitting the line on the right side. 3 is hitting, 2 is hitting on the right, and so on. The excess is on the left. There are 2, and you're going to get similar areas, but not the same. So I assume these are supposed to line up. They don't look like they line up, but I think they're supposed to line up. So 2, we know this is 7. What's 7 times 1? 7. So that first one is 7. The next one is 8. So we got 7 times 1, 8 times 1, that's 8. 9 times 1 is 9. 10 times 1 is 10. And 11 times 1 is 11. 21, 30, 38. 38 and 7 is 45. Somebody check my math. Well, I'll just do it right here, 45. All right, now you do this one. Find the area according to the right Riemann sum. Do that right quick. I'll be doing it quietly. Somebody want to tell me what number you got?
I got 50.
I got 50 also. So on the right, that would be 50. Now I want you to write that one down. I'll blow it up again. That's a good indicator of the left and the right Riemann. Left and right. I wish I could move it there. All right, let's move on to 5.2.
It was 114.
Dang, we started late. Okay, well, I want y'all to work on 5.1 through 5.3 because we have covered 5.3. 5.2 is a continuation, kind of a mix. You will be asked to count area under a curve, the boxes. They're going more graphic, finding the area graphically in 5.2. And then in 5.3, you're actually doing the antiderivative. Okay? So be working on those 3 sections of homework. Capiche? Let me look up the roll.
Yes, sir.
Turn this off and turn this off. And